Hello class 10. Today in this video we are going to discuss about that is a new chapter that is called machines. Okay, so under this topic we will today we are going to study about the just technical terms regarding machines and what are their functions and uses of simple machines are there, what are their advantages. So dear student, in our daily life we always just do a lot of work with the help of simple machine. What is simple machine? Simple machine is that which makes our work easier and faster. This is a concept. Okay, means machine is a device which makes our work easier and faster, and one thing also which saves our time also. So machine has a lot of advantages in our daily life. Okay, that is, it is easier to open a nut by the use of wrench, and this thing also you have just performed in your houses also, that it is easier to open a nut by the use of wrench than to open it by hand. Okay, it will be quite difficult to just open a nut by with the help of hand. Second, we can also say that it is difficult to pull up a bucket of water directly from the well. We have to apply a large effort, we have to apply a large force in pulling the just bucket full of water from the well, but it is quite much easier to pull it with the help of pulley. So wrench, pulley, levers, all these are what? All these are the simple machines which makes our work easier and faster. So today in this video we are going to discuss about some fundamental uses and functions of simple machines. So generally we know that the first advantage of simple machine is just it acts, we can say that it acts as force multiplier. Okay, it acts as a force multiplier. What does it mean, force multiplier? Force multiplier means simple machine is helpful in multiplying the forces, means in a less effort we are able to lift a heavy load. Okay, this is what we call the force multiplier. Okay, if you apply less force and more gain we are getting, more output we are getting, means more load we can able to lift with the help of just a simple machine. Okay, we can take the example, suppose we can take the example that if you want to lift a just car. Okay, just if you want to lift a car, okay, then and if you apply here car jack, suppose this is a car jack, if you are just applying a lesser effort, it will helpful in lifting the just load. Okay, it will just lift this heavy car upwards. So this is a simple machine. By applying less force we can able to just lift a car. Okay, so this is a simple machine, that is we can say the car jack is a kind of simple machine which is helpful. So it acts as a force multiplier. Directly as a whole we can say that it acts as a force multiplier. So the first advantage is of simple machine or a machine, we can say that it acts as a force multiplier. Okay, suppose we have to just lift just a stone. Okay, we can just we can also use here just a rod. Okay, we applying less force we can able to easily roll it. Okay, so with applying less force we can easily able to just lift a heavy load, or we can do some work in a heavier one. Okay, if you want to just you can take the example also that this is, suppose this is well. Okay, this is well, and if you want to just pull a bucket full of water from the well, so you can also take just pulley. With the help of this you can easily able to just easily able to lift the water with the help of this thread. while with this simple pulley, just fix the one end point fix. So single fixed pulley is also helpful in just doing the work. Okay, so this is also helpful in providing a force multiplier. With lesser effort we can able to lift a heavy load. We can also take an example of trolley also. Okay, with the help of wheel and axle we can easily apply less force, and heavier load it can able to carry. So all these are the examples which makes our work easier and faster. Okay, so these are simple machines and also helps in a force multiplier. Okay, second thing, if we consider that simple machines are helpful in changing the point of application of effort to a convenient point. So in changing, we can write, in changing the point of application, of effort to a convenient point, means in changing the point of application of effort to a convenient point. This is also one of the important advantage. How we can able to just describe it? We can take the example of bicycle. Okay, we can take the example of bicycle. How? Suppose if you talk about a bicycle, okay, I am just doing the, if we are making this is, suppose this is here pedal. Okay, and this with the help of chain. In this also, here is a pedal, means here we are applying the force, and the lace force is just attached with the rear, this is rear wheel, and it is helpful while applying a lace force on the pedal. Suppose it is connected with the chain to directly to the rear wheel, it is helpful in rotating the just wheel. So applying lace force, here the point of application of effort to a convenient point we can ably changing here while pedal to the rear wheel. So we can say that the rear wheel of cycle rotate it starts rotated by applying a effort on the pedals attached to wheel, toothed wheel, we join to a rear wheel with the help of chain. Okay, so in this case also the point of application of effort is changed from pedal to rear wheel. So in this case also we can just take the advantages in changing the point of application of effort to a convenient point. Okay, we have discussed in this way. So we can also just describe just third advantages. We can take that in changing the direction of effort to convenient direction. This is also one example in changing the direction of effort, in changing the direction of effort to a convenient direction. How we can determine this? With the help of example, that it is also helpful in changing the direction of effort, means whatever the effort we are going to apply, it can also helpful in changing the direction to a convenient direction wherever we want the work done of load. Okay, so suppose example we can take this. Suppose we have to lift a water full of bucket from the well. If we directly pull it, the bucket from the well full of water, we have to apply a large force. Okay, and we will apply with our hands directly upwards from the well, and it will be quite difficult for us. Okay, we have to apply a large force. But if we apply a pulley, what happen? With the help of pulley, it can easily be just able to lift in the downward direction. Means with the help of pulley, we are just applying the force in the downward direction, and without pulley we are applying the force in the upward direction with our hands without the use of pulley. So it is useful, it is helpful in just changing the direction of effort to a convenient direction. And we can just take one another advantage, that it is also helpful, means machines are also helpful in obtaining a gain, obtaining a gain in speed. Okay, obtaining a gain in speed. What does it mean? Means it is also helpful in obtaining a gain in speed. We can take the example of scissors. Okay, we can take the example of scissors. With the handles of, we are applying a less force on the scissors, and what happened, it just able to just do a large, there will be, if you are just applying a less force on the just handle of the scissors, what happen, it will move a little. Okay, and what happen, it will just there will be a greater movement of the just blades of the scissors. So while applying this, we can easily able to produce a greater movement of load by smaller movement of effort. So this is also a great advantage of just machine. Okay, so we have learned 4 advantages, that is machines can act as a force multiplier. Second one is in changing the point of application of effort to a convenient point. Third point, we have studied that in changing the direction of effort to a convenient direction, we had taken the example of just lifting a bucket full of water from the well with the help of pulley, and in obtaining a gain in speed. So these are the advantages of machines. Okay, so all these are the advantages of machine. So how we can able, as a whole, how we can able to define machine? We can define machine is a device. Machine is a device which can either overcome a large resistive force, means a load is also a kind of force, and effort is also kind of effort. Just keep in your mind that whatever the effort is we are applying, that is also force, and whatever the load lifted, that is also a force. So this is what the advantages of machine. So here is a just a new topic here that arises, that these are the advantages, and these are advantages which is helpful in doing our work easier and faster. So there are some technical words we have to go through, that is what is load. Okay, load. What is load? We have told that load is also a force. So load is the resisting or opposing force to be overcome by machine. Means load is that resistive force, that opposing force, okay, which is overcome by machine. So it is a simple example that whatever the effort is applied on the load, that load is just overcome by the machine, and this is what we call the load. Means this is a kind of resistive force, this is a kind of resisting or opposing force to be overcome by machine. Okay, this is called load. And what is effort? What is effort? How we can able to define effort? Effort, the force applied on the machine to overcome the load. Means whatever the force we are applying externally to overcome the load, that is called effort. Both are forces, but we have to define it. Means whatever the resistive force or opposing force to overcome by machine, this is called load. And whatever the just force applied on the machine to overcome the load is called as the effort. So load by effort. So a new topic here, that is mechanical advantage. Okay, what is mechanical advantage? We have to study here. MA, that is mechanical advantage. All these are the advantages of the machine. So as a whole, we are going to just lead what is mechanical advantage. Mechanical advantage is nothing but it is a ratio of load lifted. Okay, this is a ratio of load lifted divided by just effort applied. Okay, so mechanical advantage is nothing but it is a just a ratio of the load lifted. Means whatever the effort we are going to give to overcome the resistive force, that is load, it should be lifted. Means while just giving the less effort, load is how much load is lifted, that is what the mechanical advantage. Okay, so these are the just properties of machine, that is mechanical advantage, and we will also discuss the velocity ratio and efficiency also. Okay, so while using a machine to overcome a certain load, okay, while using a machine to overcome a certain load, if the effort needed is less than load, means if the effort, we can say that if the effort needed is less than load, one condition is here, when the effort needed is less than load, okay, what happened, the machine has mechanical advantage greater than 1. In this case the mechanical advantage will greater than 1, means what, if the effort, we are applying the effort on the machine is less than that of the load, in that case mechanical advantage is greater than 1. In this case it has a mechanical advantage greater than 1. Okay, this is the first case. There are some criterias also. So this is the first case, and the second point is, if the effort is equal to load, or we can say that load effort is equal to load, in this case the mechanical advantage is just equal to 1. In this case mechanical advantage is equal to 1. And the third one is, if the load is greater than effort, in this case the mechanical advantage is less than 1. These are the three criterias. Okay, if the effort is less than load, mechanical advantage is greater than 1, and if the effort is equal to the load, mechanical advantage is exactly equal to 1, and if the load is greater than effort, in that case mechanical advantage is less than 1. We will take one of just examples, that if effort is less than load, okay, how we can able to describe with the help of example. We can take the example of this one, that is a car jack. With the help of this simple machines, which is able to apply a large load upwards. Okay, so this we are applying here less force, and load is lifted heavier, so effort is just less and the load is greater in this case. So in this case mechanical advantage is greater than 1. Okay, in case of effort, when effort is equal to load, so how we can able to just take the example. Okay, just whenever the effort, whatever the effort we are giving, and the load is equal to that effort is equal to the load, we can take the example of this one, in this advantage, where we have just taking the example in changing the direction of the effort to a convenient direction. Suppose we have taken the just lifting a bucket full of water from the well. Okay, in that case we have just given that how the simple pulley, a single fixed pulley is helpful in lifting a bucket full of water from the well. In that case, whatever the effort, it is helpful only the changing the direction from the upward to the downward. Okay, okay, so whatever the effort we are just giving, that much load is just we are providing. Okay, whatever the effort we are just providing, load is lifted from the well in the form of bucket full of water. So in this case mechanical advantage will be 1. And what will be the condition when load is greater than effort? Load is greater than effort. In this criteria we can helpful in just we can say that example of just suppose a hockey player. Okay, you have seen a hockey player playing in their ground. Just with the hockey, it's applying a larger just effort. Okay, or we can say that load in this case. Okay, here the third point we have discussed, that effort is greater than load. In this case mechanical advantage is less than 1. Okay, this is the third point. By mistaken it was written that load is greater than effort, so by mistake. So here the first case was effort is less than load. Okay, so in this case mechanical advantage is greater than 1. We have taken the example also of the just car jack. Okay, second one is the effort, when the effort needed is equal to the load lifted. In this case mechanical advantage will be 1. we can take in the example of with the help of single fixed pulley, how we can able to just pull a bucket full of water from the well. And the third point is, you have to notice here that when the effort needed is greater than load, okay, in this case what happened? In this case, mechanical advantage is less than 1. We can take the example of a hockey player which is playing in the ground while just lifting a small ball, okay, just a small load, okay. The large just effort is needed, okay, to pull it by the hockey player, okay. So this is what the large effort, by bending its body also, a large effort is needed to just pull it outwards, pull it up to the net, okay. So this is what the condition when the effort is greater than load, mechanical advantage is less than 1. So dear student, up to this level just go through. We will meet in the next video. Thank you.